In this video, I will be talking about the electric field line. The electric field lines are imaginary lines that are drawn in a space around a charge so that the tangent on this line gives you the direction of the electric field. Let me explain this one. Let's say you have one negative charge, the two negative charges at this point. If you have positive charge at this point, then this negative charge will attract and this negative charge will also attract. So the total or the direction of the electric field at this point due to this negative charge is towards, and due to this negative charge it is again in this direction. So the total electric field at this point is 0. So you see there are so many arrows here. So what does this direction gives you? This direction gives you the electric field. If we put a positive charge here, and if you draw a tangent at this point, then that will gives you the direction of the electric field, the total electric field due to this charge and this charge. Okay, for example, here at this point, this arrow tells you the direction of the total electric field at this point. Or it also tells you the direction of the force. If you have a test positive charge, the particle will move in this direction. Or at this point, it will move in this direction. And if you have the test positive charge here, then the direction of the force will be along this direction. Or this gives you the direction of the electric field. Alright, so if you draw a tangent at any point, the tangent gives you the direction of the electric field. Now let's say what happens if you have two positive charges. So the two positive charges, so let's say you have one charge here, positive charge here. Then due to the positive charge, the electric field is in this direction, and also due to the negative charge, the electric field is in this direction. So in this case, the total electric field is along this direction. So again, if you draw the tangent at any point, the tangent at any point gives you the direction of the total electric field. Okay, how do you map out, how do you find out this kind of electric field lines? So the way is, now let's say you have positive charge and negative charge. If you bring a positive charge here, then it will try to move in this direction. Now if we bring the positive charge here, it will move in this direction. If you bring the positive charge here, it will move in this direction. So if you just have an imaginary test positive charge, then it will try to move in this direction. It will try to move along this direction at this point. So if you keep drawing the tangent lines, then the tangent lines gives you the direction of the electric field. Okay, and there are so many important things about the electric field lines. The electric field lines are a continuous line. You do not see an electric field line, a broken line. It is continuous. And at this point, you see there are more packed lines than here or than here. Okay, so the more the packed lines means the stronger the electric field is. So if you look at closer to this area, if I let's say take a unit circle here and a unit circle here, more electric field lines are here than compared to here. What does that mean? The electric fields are much more stronger near than they away. In this picture, if you take a small area here, then you do not see the electric field lines here. That means the electric field lines are much weaker here, okay, compared to any other area. So the more the electric field lines are, that means the stronger the electric field is. And also, if you look here, the two electric field lines never intersect. It cannot intersect. Okay, so it is always it can never intersect. If you look any two electric field lines, it never intersect. And the electric field lines always start from positive. It always originates from positive and terminates on negative charge. It always starts from positive and ends on the negative charge. So these are the important concept about the electric field lines. So again, as I mentioned here, the red arrow tells you the direction of the electric field. Okay, the arrow gives you the direction, and if you draw the tangent at that point, that gives you the direction of the electric field. Okay, that's it about the electric field line. If you have any question, please